So now we're going to take a look at a algorithm that has a time complexity of n squared. Right, and if we remember from our big O notation, this is big O n, and that's linear search. Right. Now we're going to take a look at one that is n squared, like that. Right, slower. And so the example that we're going to take a look at is linear search in a two-dimensional array. Okay, and what is a two-dimensional array? Well, here's a graphical representation of it. It's an array where every element is another array. Okay, and so if n is equal to 10, then here we have a matrix of n by n or 10 by 10. And you could see here that maybe if this whole 2D array was called arg, then arg sub 0 would be this first row. Right? Arg sub 1 would be the second row. Arg sub 2 would be the third row. And arg sub 3 would be the fourth row as we move our way down to n. Okay. But you could see here that each element is an entire array in itself. Right? So that's what a 2D array is. It is an array where every element in the array is another array. Okay. And so let's say we were doing the same algorithm on this this data structure, and what are we doing? We're looking for the number of 4s, and if we find a 4, let's print them out. So how would that go? Well, we would go ahead and look in arg arg sub 0 sub 0. That's how we manipulate 2D arrays. You say sub. So sub 0 is the row, and then after that is sub 0 the column. Right? So we talk in terms of rows and columns, and we check. Is arg sub 0 equal to 4? No, it's not. We iterate again. Is arg sub 0 sub 1 equal to 4? No, it is not. Sub 0 sub 2 equal to 4? Nope. Sub 0 sub 3 equal to 4? Nope. Sub 0 sub 4 equal to 4? Yes, it is. We print out a 4. And we keep going till we get to the end of the first row. When we do, then we're going to increment the row to 1, and we're going to start with 0 as a column, and we're going to consider each of these elements and check while checking if they're equal to 4. If it is equal to 4, we're going to print it out. Right? Sounds easy enough. Now, how does the code work? Well, if we take a look at this here, it's basically the same algorithm as what we had over here, except the only difference is that the array is constructed differently. Right? How is he constructed? Each element, which is delineated by a comma, consists of another array. Right? So we got an array here, array there, array there, array there, and array there. Right? So what this is a 2D array. It's an array where every element consists of an array, and usually people kind of code it like that so that they can have a better understanding of how that relationship works. Right? And so let's make this 4 by 4. So here we have 1, 2, 3, and 4. Okay, and then we'll just get rid of these over here. So now here you can see we have an array that has 4 elements, where every element has 4 elements, right? So what we can say here, if n is equal to 4, then we can say this array has a size of n by n. Okay, and so let's go ahead and run search on the array with the value 1. Right? So we're going to do the same thing. If we find the 1, we're going to print them out. How does that work? Well, up here, arg is equal to this 2D array. Right? The search number is equal to this value here, 1. And we're going to come in here and we're going to have a for loop that is going to run the length of arg. And what is the length of arg? Well, the length of arg is how many elements arg has. And how many elements does he have? Well, you might look at the whole thing and you would say 16. But that's not true, right? It has 4 elements. It has 1 element, 2 elements, 3 elements, 4 elements, right? Now, if you asked how many elements does the first element of arg have, you would say 4, right? Because this first element here, which is the array, has 4 elements in itself. It has 4, right? Yeah, it's like 4 integers. And so back to the point is length of arg would return 4, not 16. All right, and so I is equal to 0, 1, 2, 3, 4. I'm sorry, 0, 1, 2, 3. Once I increments to 4, then this for loop is going to break and it's going to stop going. It's going to be the end of search, which is going to come back here, which is going to be the end of main, which is going to come back to line 19, and then move on to 20 and end the program. All right, great. Now you might be looking in here and saying, hey, wait a second, there's another for loop. Right? That must be a mistake. No, it's not a mistake, right? So to iterate through a 2D array, what you need to do is have a nested for loop. You need to have a for loop inside of a for loop. This for loop here is going to iterate through the rows. Right? This for loop here iterates through the columns. All right. So how does this work? Well, this is going to, I is going to be equal to 0 to 3, right? Let's go through the first iteration of this outer for loop. The first iteration of the outer for loop, I is equal to 0, right? Then we come inside the body of the for loop, and hey, we have another for loop. So it's going to run the inner for loop. And the inner for loop, I is going to equal to 0. And then we have it run for the length of arg sub I. And what is I? Well, I is 0, because it's the first iteration of the outer for loop, right? So I is equal to 0. And j is equal to 0. Well, what's the length of arg sub 0? Well, what is arg sub 0? It's this guy right there, right? And what's his length? His length is 4. So that's going to be replaced with 4. J is going to iterate from 0 to 3. Okay? And so let's say we go into the first iteration of this inner for loop. Well, j is going to be equal to 0, and it's consider this element. And what is that element? It's arg sub I sub j. And what is I? Well, what was I? We're in the first iteration of this outer for loop. So I is equal to 0. Now we're in the first iteration of this inner for loop. So j is equal to 0. And what element in the 2D array is that? Well, arg sub 0 means which row? That's the first row, right? And sub 0 means the first element in that first row. So we're talking about the 3. And we're saying, is 3 equal to search num? What is search num? Well, it's the second argument of search function, which is right here. So it's equal to 1. So it's asking, this question is asking, is 3 equal to 1? That's not true, right? It's not true. So it's not going to do that. For loop's going to iterate again. J is going to equal to 1. I is still equal to 0. I is not changing. I doesn't change until this inner for loop finishes. And then the body of this for loop is done. The outer for loop is finished. It comes back up, and I increments from 0 to 1. All right. So I is still 0. I is 0 here. J increments to 1. And we're checking, is arg sub 0 sub 1 equal to 1? And what is arg sub 0 sub 1? Here's the 0 element. Here's the 1 element of the 0 element. And it so happens to be 1. So is 1 equal to 1? That's true. 1 is equal to 1. So it's going to print out arg sub 0 sub j. Right? So now it's going to print out that 1 right there. Okay, great. Now it comes back, iterates again. J is equal to 2. And it's checking is 3 equal to 1. No, that's not true. J increments again to 3. It checks is 4 equal to 1. No, that's not true. Okay. So now it's going to stop the inner for loop. That's the end, which finishes the body of the outer for loop. So the outer for loop is now going to increment I, not from 0, from 0 to 1. So I is equal to 1 now. It comes inside to the inner for loop. The inner for loop is starting all over again. So j starts out at 0. So what we're considering when we come in here is arg sub 1 sub 0, right? And so what are we considering here? We're saying the second row of arg, which is this element here, and we're considering the 0 element, which is the 3. So we're saying, is 3 equal to 1? And then we're doing it over again. Is 7 equal to 1? Is 1 equal to 1? Yes, right? And so on. So you can see here that this nested for loop is going to iterate through this 2D array, right? And so what is the time complexity of this algorithm? Right? What is it? Well, this here is n, right? The number of elements. This here is n as well, right? And so you can see here for every element n, we need to iterate n times. right? And we need to perform a calculation or do something n times, right, for every element n. So what is the time complexity? It's n squared. All right. And an easy way to analyze this algorithm is just say how many nested for loops are there? Well, since there are 2 and they're each iterating n times, then we could easily say that this algorithm has a time complexity of n squared. All right. And so if I ask you, well, what about a time complexity of n cubed? Well, how would that look? That would look something like this, right? Where you have a nested for loop. You have a nested for loop inside of a nested for loop inside of a nested for loop, right? And the way that we do it in Python, the way we do it in programming is we usually do ijk, right, for the iterating variable. And so if I looked at this algorithm here, I would say, well, what's the time complexity of this algorithm? Well, it's iterating n times, and for every element n, it's iterating n times, and for every element of n, it's iterating n times. And so altogether, how many times is it performing a calculation? And it's n cubed. Okay, so that is that.